Hi, I have a very specific question about solenoid brakes for servo motors and how they relate to robotic arms. As you're probably aware, if a servo motor, a hobby servo motor, has a lot of weight on it, as in the case of an arm or a head or a leg or something, gravity will simply allow it to just fall and crash. Same with an arm. If that was an arm hanging that way, it would, fall down until it faced down towards the center of the earth. To prevent this, we need to install a brake. Now, the solution is to make a brake engage whenever there's no power in such a way that this cannot happen unless the instructions from the controller or the microcontroller are telling it to move. So we need to run power to the solenoid in such a way that it only releases the brake. It's called a pull solenoid because when power is engaged, it pulls inwards to disengage the brake. So it's an off brake. So however this brake is going to be incorporated into any of the designs, it needs to pull away when there's power and push back up when there's no power, so the robot can hold its pose for infinity until power is applied, in which case it disengages and then gravity can do what it wants, but at that point the servo has been given instructions to move. And then the instructions stop and the brake re-engages. That is a solenoid that's oversized, but we bought this for the prototyping examination process. So we could ask you this following question: how do we make sure this solenoid doesn't do the following problem, have the following problems in the circuitry? So this is a direct circuitry question. The power in that direction, going over there, is a 46 amp 7.5 volt transformer, as opposed to a bunch of little 1.5 volt batteries in an array. So that's going to be our power supply. Let's turn this fridge off. Sorry, folks, need light. Alright, that's the fridge, by the way. Okay, so the problem is this. So we've got power coming in here into the little receiver, the receiver for this transmitter. Okay, so that power is going in there, and then this is just an extra bit of wires off a splitter, which is only relevant if you say it's relevant, because I don't know how to use that. If I do need to use it at all, I could have bypassed this yellow splitter and it's gone directly in to make the cables neater, but I just wanted you to know that there's an option there. There's also an option of wire splicing further down the line before we get to the transmitter, because what happens is I want to know the answer to how to make this go 100% on, 100% on or 100% off, and nothing in between. At the moment, because the transmitter is telling the receiver to release a certain amount of volts slowly and so on. Okay, so these two are plugged together. What I've done in this sloppy wiring is I've intercepted the red power line from the transmitter and also the transformer and the battery into this. It's actually buzzing at the moment. There's a buzz to it. It wants to move. I don't know why there's power there. Maybe this needs to be changed the settings a bit. It feels a bit more relaxed, but maybe I need to tweak that. So I want to remove any interference, and that could be simply a matter of adjusting this setup or plug it into a more accurate microcontroller. And I assume that could be the problem, so long as there's never power coming towards this when it's not asked for. And I would assume that requires electric tweaking of the transmitter and transformer. And whatever the controller is, okay? So that's a minor problem, hopefully. Because I would like to think that there's no power coming to this at all when the robot's just in standby mode. I don't want power just constantly buzzing through the system, because I expect these robots to be turned on 24 hours a day, 7 days a week, 365 days a year. Okay, so there shouldn't be really any power going in, as far as I'm aware, or if there is, it should be very minimal. And if there is, then there's power going to the solenoid, which is disengaging the brake. So when I have a robot with lots of pairs of solenoids and servos in every pan or tilt segment, I need them to behave themselves. So at the moment, if I move this, you can see that the servo is activated, and also the brake's already engaged because it sort of plays up. It doesn't have a spring on it yet, but just imagine there is one. So if I move that, yes, you can see it moves very quickly. But what happens also, which is problematic, is that if I move it slowly, it takes a while to engage. Can you see that? Can you see how slow that is? Because I'm adjusting it slowly. See, watch the solenoid on the floor. See how that's slowly going in? There can never be a time in which that is slowly going in. It needs to be 100% on or 100% off, no in between. Because otherwise, imagine this dragging around on the brake when it's trying to rotate on whatever disc setup I've got. So there's the first problem. That needs to be 100% on, 100% off as soon as this receives any signal at all. Capiche? Second problem. That is a 6.5 volt, probably less than 1 amp draw little servo motor. When I start using the bigger ones, these have a holding current of 9 amps. They're 7.5 volts. Doesn't matter. The 7.5 volt works fine, because 1.5 volt doesn't make any difference in this problem. It doesn't cause any problems. Here, I am activating the power supply on the same line, same as that other one, and you can see the cable colors are correct. Now, the solenoid is playing up. It's as if the wiring can't decide how to get through to this high draw, and that's you can see I'm moving all the way to left and right. This is too heavy in terms of its needs to get any strength. And just to show that that's not a bung servo, oh, you see what just happened then? 2 wires touched down there and it forced it to move around. Because I should probably show you that again. I need your circuitry responses. So at the moment, we're going via the solenoid, but I can bypass the solenoid altogether, so the electricity will take its shortest route. And you can see, when I touch these two together, see, kind of default position. In fact, if I hold them together, these two little two red lines, they're both the live wire coming from the power supply. Now, it works fine, see? But when we let, so that is being ignored. The solenoid is being ignored. When I do that, the wire's going straight through like it normally would into there, which means it doesn't have to deviate off course, give power to this, let that complete its circuit, and then come back through. With this one, it could tolerate that in a messy way, in a completely unacceptable way, in this sloppy way that I've developed here. Because I don't know how to use relays. I don't even know what a relay is, but I've heard transient relays and all these different things. I only just discovered what a solenoid was 2 days ago, okay? So I don't know what I'm doing. But this is the ultimate braking system, I know that. Because I don't want to have to create little coil suction magnets, because we've discovered that solenoids actually are the same as what I was inventing, and they already exist. This one is obviously really heavy. I would never use this particular solenoid. I would use a little one. And I don't know if this little one would, be triggered quicker, because it only requires a very small voltage to be activated as quickly as possible, which is one of my first solutions when I do get a chance to buy a solenoid. But in Australia, we don't have many shops that sell anything at all. I mean, this is 12 volts. The system's running on 7.5 volts. This is really big and heavy. It's really heavy. So I don't think Australia really has anything for robotics. There's maybe 1 or 2 stores, and they really don't know what they're doing in there. So I've asked them 1,000 times. I've spoken to many of them on the phone and through emails and things. They try to be helpful, but it really can't compare with what's happening in some of the countries. But to be truthful, not many people in the world know much about building a braking system for servo motors. Okay, so as you can see, it works fine when that's going through, and not at all, or very little, when that's happening. Even the solenoid itself doesn't really like it. See, it's shaking about and so on. So my question is, how do I wire this properly? I want this to move 100% perfectly, and I want the solenoid to close 100% perfectly, without having to worry about sharing power, ever. Do you understand? The solenoid could receive its initial power from prior to this. This is going to slow down the voltage supply along the route. So I was thinking, if we go directly from the live wire output, say in there, and then somehow from one arm of this blue stuff, this solenoid cable, and then complete the circuit after this has received power in the black output or something, it'll be fast enough to disengage in time to disengage the brake so this can freely move without having to worry about problems with gravity and so on. But I've tested it and that doesn't work. So please help.